it's Movie Monday, and today we're down here to visit some of our close friends, Brett King at King Shocks. Let's head on inside and see what makes King Shocks the king of shocks. Hey Brett.
Hey, how you doing, Vaughn?
I'm doing very well.
Buddy? Good to see you.
Thanks for having Rebel down to King Shocks today, and do you have a few minutes to show us around?
Yes, I'm glad to see you guys here. Yes, let's come on back. I'll show everybody around.
Thanks. Good news is I've been down to King quite a few times, and I've seen how they lay out their shop. You know, some of the area that we're in right now is actually their repair facility. And Jason, pan over to these. We just have a look at the size of some of these shocks. These are actually off a trophy truck, and they're coming in here to get rebuilt. Now, after they've been run hard in the desert, you really want to have these gone through. You know, the seal is going to heat up a lot. You want to have these things gone through and make sure that they're ready for the next race. And of course, they're massive. This is actually the rework facility. Shocks are coming back here and getting redone or reworked for the next application or the next race. Brett, tell us about how you lay out the shop. I know in the back corner over there, we have your coilovers that are in stock, ready to go for assembly. How else is the rest of the shop laid out?
Yeah, well, you know, we have all our spring inventory is over here. We have at least 10,000 springs at all times. We got, as long as it's for a coilover, we have the spring for it. We got everything here. It's in stock. You know, a customer can call and get it very easily in a few days. Over here on the other side, just in front of it over there, is all our shipping department. It's where all the packaging and shipping is done to the end user or the dealer, or will call. Basically, it's our will call slash shipping area is over here on the left. This right here is, obviously, you can see they're rebuilding shocks. In this area, they go through and they completely take the shocks apart, polish the shafts, change all the rubber parts, inspect the shock, you know, get it back up into good working condition here. Over here, he's building all new shock absorbers. The guy has, these are all new assemblies. Put them all here. He has his station where it has all his parts around him to build the shock absorbers. So, and back here there's our ultrasonic tanks and all our wash tanks to clean them and service the shocks. People will bring shocks in on crates, or we'll put them on a cart. They'll go from a cart, they'll get tagged, they'll put up on the shelf with their name on them. And then behind us here is kind of our staging area. All shocks, when they're brand new and we make them, we put them together and we pressurize them with high pressure of like 300, and we let them set for a few days before we ship them to make sure that there is no leaks or any obvious thing the matter with them. Here you can see we have all our welding departments of all the bypass tubes and all the shafts and all the tops, and everything that we weld is back there, along with our deburr after we machine the parts, which we're going to take you to the machine shop in a little while. All the parts get deburred, and then after they get deburred, they will come over and they will go for an outside process. They'll either go to stock or they'll go to an outside process of maybe an anodize or a plating of the cylinder, or a hard anodize. If it goes to outside process, we'll do that at that time.
So down here at King, yes, they're welding their shocks up right now, but they're not only just welding up the shocks. Their resi mount brackets, just about everything is actually welded here in the United States and actually in their facility. Brett, tell us what's going on with the shocks that's going on here.
Well, over here to my left here is he's welding a bypass tube shock up. We do no MIG welding here. All our welding is all TIG welding. You know, it's the highest form of welding. You know, these guys are very good at what they do. We're over here in the bypass department here, and in this department, you know, we take we get finished product here after we find up machining it in the machine shop. We bring it over here, and over here we will we'll lay out custom bypass tubes where we'll take a print and we'll design where we're going to drill all the holes and produce and manufacture the bypass tube shocks all here in-house, right? Other than any of the plating stuff, we make everything here, right? From the machine work to the welding to the deburr to assembly to shipping, the whole thing is built 100% here at this facility. This machine here next to me is a CNC machine that is designed to drill the ports in the cylinder. These ports are not laid out by hand. These ports are all designed so that they're done on a CNC with a computer program so that one bypass shock will match the other bypass shock, as opposed to just a standard drill press job. This is a bunch of our shock oil right here. You know, we have basically two different types of shock oil. We have a super high temperature shock oil that we run in some of the land trains.
Okay.
Believe it or not, those guys are getting their shocks hotter than some of our normal trophy truck shocks. They'll get them 400 to 500 degrees on some of those land trains. You know, we're here in, this is our final stage. After the shocks get assembled, they come over here into our shipping department. This is an example right here of some of our 24 karat gold shocks that we built for one of the princes in Dubai.
And this is really 24 karat gold.
It is really 24 karat gold. This is all staging over here. It has some of the, you know, anywhere from a UTV shock to a trophy truck shock to a Jeep shock for Rebel. You know, the stuff goes all over the world here. It sits here, it gets packaged. If it's a large order, it goes straight to a pallet. And then we got all our repairs and stuff that sit over here too, getting ready for packaging and for shipping out, or will call.
That you guys do when you're actually putting the shocks together, especially when we're shipping them. They're being boxed, but they're also having the foam spray put inside them. And that foam spray is going to hold that box really nice and tight, protect the shocks, protect the bump cans, the whole 9 yards. So the shocks aren't getting bumped around or anything inside of there with that foam spray. Right now we're up in King Shock Technologies Design Center, and Jeff, their lead engineer, is going to walk us through how they design their shocks. Jeff, tell us about SolidWorks and why you guys use it.
Well, Bond, with the 3D engineering, then we're able to completely see how the parts fit together. We're able to make assemblies, check fitment, see how the whole assembly works before we go and make any parts. We're able to do it much faster, much easier than before with only 2D designs. So we're able to more fully see everything that's going on.
I noticed these shocks here, some of them have got 40, 50 different components. Can you design all of those components in SolidWorks and see how they're actually going to work together?
Yeah, we can design the parts individually or as assembly together, that we're able to make a few parts and really make them fit together well.
And then after you've actually designed these parts, I noticed we've got the 3D printer going over there. Is that the next process? You're going to build them on the 3D printer and see how they fit together?
Yeah, from SolidWorks we're able to go directly to our 3D printer, so it prints out the same files that we have, and then we're able to not only see them on the screen but to touch and feel them. And then from the 3D printer, the next step is the machining. So the 3D printer is a much cheaper and faster alternative to prototypes and machining. Here are some examples of 3D printed parts that we've done. These are some different, slightly different designs that we're able to lay out on the table, quickly make them, and then select which ones we like the best, especially for like the finned reservoir that we've spent a lot of time on. We can sample new end caps or new fitments or new parts, and not only are they give us something to hold, but they're relatively strong that we can install them onto a shock. We can use them for some very light duty field testing, and we're able to then qualify and go on to the next phase of the engineering.
Earlier on you had mentioned to me, Jeff, that you guys can actually take these pistons, which are plastic pistons, put them inside the shock, and when we get to see your shock dyno, you run them inside of there to test the concept and theories.
Yeah, those are two good tools that work together, that we're able to, if we want to evaluate a new piston design, we can take it straight to the dyno, get some flow characteristics, and very quickly know if it's going to be an improvement or not, and if it's giving us what we want. It's not a full piston that we can necessarily run on a truck, but it very well works for the lab. There's our part.
So Brett, you brought us over here to your other facility, your other building. It's across the street from your main shop. What happens inside of here?
This shop over here is basically our R&D facility. It's also where we do all the preliminary fitment of all of our products. Here in the OEM facility here where we're charging shock absorbers here. And at this point he's going to put gas pressure in the shock absorber. When the pressure goes into the shock, that also forces the pressure against the oil, which in turn puts pressure inside the shock, which shoots the shaft out. The pressure in the shock serves the purpose of to keep the oil from foaming. So when we oil a shock, we might be oiling 50 of them at a time. When he oils here, he's getting all the air out of the system. He's set the floating piston in the reservoir, and he's getting all the hydraulics. We're sitting here in front of some of our shocks, and we want to talk a little bit about our compression adjuster. These compression adjusters control the flow into the reservoir. As you adjust them, it will restrict the flow of fluid into the reservoir, which consequently will give you more compression dampening if you want your shock stiffer, or if you open them up, it makes them softer. Got them so that they really, really work properly so that you can tell a big difference instead of more of a gimmick. We wanted something that was truly, truly worked on the shock absorber. It's a very, very nice option for somebody who is a little bit more than just street oriented. If they want to go into the dirt, it gives you an option of immediately being able to adjust your shock absorbers. It's a very, very nice feature to a stock vehicle. Somebody who wants to run trails or goes Jeep and use it for more than just a grocery getter.
Okay, so here we have the spring tester. This is our newest piece of equipment. This allows us to test either individual springs, if we're doing like a quality check or we want to learn more about the actual spring, or we're able to put on a coilover where we can see how the two springs work together. This is special equipment made just for us, that nothing else like it, with the amount of force it can produce, the amount of stroke that it has, and it was made to fit our shocks as well. The spring tester allows us to more closely look at how the springs are working, see the forces that it makes, and to see what's actually happening on the car. This is the next step of product development before it gets to the field, that allows us to do laboratory testing and to document and learn more about how the shocks are working.
You can see the two different springs compressing at slightly different rates, and right now it's about to hit that secondary nut and then compress that lower spring.
Right, so there's a lot of variables there that we have to work with, the different spring rates, the different spring lengths, as well as where we want that second spring to take effect, and it hits the coil nuts.
So a lot of you guys are familiar with dynos, but you really think about the dyno as being a vehicle dyno. This is a shock dyno, and we don't just have any shock on here right now. We've got a massive 4.5-inch King on there. Most of you guys are familiar with 2.0s or 2.5 shocks. This is a 4.5-inch shock. Not only is it a 4.5-inch shock, but it's a multi-bypass. How many do we have on here? 8 or 9?
1, 2, 3. Looks like about 8 tubes.
We've got 8 tubes. There's 8 bypasses. The bypasses are going to be used for compression, controlling the compression as well as controlling the rebound. And it has a big cooler on it as well. This is not your normal shock. This is a full-blown, as fast as you can go trophy truck shock. And I'm glad you guys have chosen to use the biggest and baddest one around to demonstrate how the dyno works.
That's right, Bond. It is the top of the line for us. This is where we're going to put on the desert racing cars, and this is the ultimate for control as well as cooling, so that we can keep the trucks running for a long time. Just as you said, we have 2.0 or 2.5 shocks for a Jeep. As the shocks get bigger, we're just able to make more force, and we're able to control the wheels. So for the dyno here, we put the biggest shock that we can have, and we're going to try to run it as fast as we can. Okay, so in the software, we're able to control a lot of variables of the dyno. We're not restricted to any sort of test pattern, so we can tell it really anything that we want to do. Speed, stroke, maximum force, and we've got the test set up, and we're going to play it now. It'll first do a warm-up cycle, and then it'll do the actual test and go through some different speeds, see some different frequencies.
So what you guys got to see just now was a shock being used in a shock dyno. The data that comes out of them lets King shocks figure out what's going to work best for each application. If we're talking about a vehicle that's going to be driven on the street a lot, then you might only be using an inch and a half of up travel, down travel, and we can measure the cycle of that inch and a half up to what, 300 inches I think you guys said?
Up to about 300 inches a second is what we're doing on trophy trucks when it hits a really fast bump. They're running the wheel speed or the shaft speed up to about 300 inches a second, which is comparable to most of your street driving that you see going up a curb and stuff at maybe 3 or 4 inches a second.
So going down the freeway, if a shock can be tuned for a vehicle as an OEM replacement, going down the freeway, the vehicle is going to drive really nice. It lets them dial it in either through some of the valving, some of the flutter valves as well, to get that nice smooth ride coming out of the vehicle on the street. Going off-road, they can also have a look-see and say, okay, well on a vehicle that's going across the desert or a vehicle that's being used on the rocks, it's going to be used at a different rate. You might be up around 4 or 5 inches per second there. They can get the data out of the vehicle. They actually install wheel speed sensors on the vehicle to get an idea of just how fast the vehicles are going, at what speed they're mostly driving at. They take the average, they look at the lows and the highs, get the averages as well, and then figure out how to tune the shock or coilover or whatever particular shock we're talking about for that particular application and for that use. Obviously, a Jeep is going to be used a lot slower than a trophy truck, and a lot of the OEM style shocks are OEM replacements for vehicles that are going to be driven on the street a lot more than off-road. That's really where the shock tuning comes in.
Everything, we order raw material. It comes into us as in bar form from maybe a Kaiser aluminum foundry. We'll get it in bar stock. Multiple different pieces that we have in the shock use different types of steel and aluminum, and it's fairly complex. Although a shock may look simple, the actual procedures of manufacturing them is fairly complex, from the design work to working with outside vendors and outside processes. And we get bar stock aluminum, we machine it all in-house, we deburr it, we send it outside to get anodized, then it comes back here, and once that process, it'll get inspected for final quality, and it will go to an assembly shelf or an inventory. At that point, those parts are waiting there for somebody to take those parts at an assembly bench to do final assembly for a customer's job. It's the whole thing from the beginning to the end is all done 100% here in the U.S. With little to no outside processes. We are completely self-sufficient. It's one of the things that has really helped speed up delivery and make us able to change our designs and maybe make small adjustments to the shock absorbers on the fly.
Brett, tell us a little bit about the history of King Shocks. How did you guys come into this business?
Well, we had, in the early 80s and mid 80s, we designed a bunch of shock absorbers for another shock company as a project that my father was working on. They had a little bit of financial problems, and, basically is what happened was me, my father, and my brother all lived at the same house, and we were all unemployed at the exact same time. We went down the street because we didn't know how to do anything except build shocks. It formed a team, right? We each have our specialty of what we do as far as design, engineering, welding. My brother is a master welder fabricator at a very young age. And me in the sales and the customer service and the manufacturing of the parts. So we all kind of had a history at doing it. We just all have our specialty as far as what we do.
Now, King really is a family business. Your father's here on a regular basis. I get to see him when I come down. Mm-hmm. Your mom stops in on a regular basis and does work here as well, as does your brother. It's great to see everybody still so closely connected. One of the great things about King Shocks is they do a lot of shock tuning. They go out to the desert with us and do shock testing, and really what we're doing out there is testing the shocks, is not to see how good their product is, but to actually tune the shock for each application.
It gives us an opportunity to test the vehicles, test the shocks, meet the customer, and help support the product. It's become an extremely important part of what we do, because I can sell shock absorbers, but they really need the backup or the support of testing and setup for people, because it does make a big difference.
I know for us it makes a world of difference. Being able to go fast when we need to go fast, having the amount of travel that we need on the Jeeps when we're off-road playing in the big rocks and having all the droop. It's very important to have this vehicle be able to drive fantastic on the street as well as perform very well and fantastically off-road too.
Mm-hmm. Yes, exactly. Like, you know, one of the things we'll do with Rebel is when we'll build the shock absorbers and then we test it, right? And when we do that testing, we take it off-road, we change the valving, we change the springs, we adjust the preload height if it's a coilover application, and you know, we get it a lot closer than just building shocks and putting something on there. We need to valve it and spring it accordingly so that in the future what we put on that vehicle has already been pre-tested.
Tell us a little bit about coilovers themselves. Why should somebody look at, you know, on a Jeep for instance, why should we run like a coilover versus a traditional spring and a shock type of a setup? What are the benefits of travel and things that you're going to get with a shock, with a coilover?
Well, one of the biggest benefit with the coilover is you can get a little bit more articulation out of the suspension that you can never get with a spring in the bucket. When the spring's in the bucket, you have a given compressed dimension that you have to work with. So if you get a longer spring and you just put it in the stock spot, it's going to droop out longer and it's going to sit higher. But that spring now is longer, so it's going to compress even earlier. So you might gain some on the suspension, but you're going to lose up travel sometimes because that spring has a given area that it has to combine or to coil bind in. When you go to a coilover, your shock mount gets up higher and you can get much longer shaft travel out of the shock, and you can gain more down travel and more up travel. And the springs are all universal fitment, so you can get dual rate springs. You also get this coil nut adjuster, which you can raise and lower the vehicle. It's very, very important, so you can raise and lower the vehicle just with this without even changing the coils. It gives you more adjustments. The more adjustable your suspension is, the easier it's going to be to set it up to the way that you like it.
Which brings me to another point, is a lot of the Jeeps out there and some of the other vehicles, the weights change a lot depending how the vehicles are built, the type of equipment that are on there. Are they running steel fenders, aluminum fenders, plastic stock fenders? With a coilover, you can actually set the vehicle up as it needs to be for that application. I know when my guys are speaking to customers on the telephone and they're trying to set up a coilover, we're going to ask things like, you know, what style of bumpers are you running? What style of fenders are you running? Do you run a winch? Are you running 37s? Are you running 35s? Are you running 40s? Do you have a spare on there? Because all that's going to come into play as to how we're going to have that shock valved, how they're going to use that vehicle, as well as how we're going to, what type of a spring rate we're going to go for to set it up initially so that you're going to get a shock that is already, for the most part, pre-tuned for that particular application. With a regular coil spring, you basically have one spring rate. When you're dealing with a coilover, you got so many different spring rates, there's so many different variables that we can match up when it comes to springs. 250 pound, 350 pound, 200 pounds, all in 50-pound increments, which lets us dial in how the spring is going to be set up or how the coilover is going to be set up. Another great benefit to coilovers is you can set the ride height. Some of these vehicles, you'll see them when they lifted, because that gas tank, for instance on the Jeep JKs, is down the one side, the vehicle leans always to the one side. With a coilover, you can actually dial in the suspension so the vehicle sits straight. There's lots of benefits to running coilovers.
Brett, I want to say thank you from Rebel Off-Road for having us down to King Shocks, giving us a big tour, showing us how shocks are made and all the different components involved in doing what you guys do.
Good. It's been a pleasure to have you guys here. I hope I've enlightened you guys. I've showed you a full tour of the shop, and from the manufacturing to the shipping department to engineering to R&D to where we actually make the parts in the machine shop. So it's been a very good thing, or good experience, I hope, for everybody. We're glad to see you guys.
Thanks.